This is the paint dispensing mixer machine project overview in ECE 4960 at Clemson University. We're Team 18.
So first and foremost is our objective and motivation. So essentially, we want to create an electronic paint dispenser that is able to mix a color based on the user's choice, and this will be done through a graphical user interface. So we want our project to be done by May 5th and for $300. So our design is created for the average hobby artist and for use in the classroom. And so this can be used in elementary schools when it comes to art teachers, when it comes to learning color theory, as well as just for the everyday artist who just enjoys the paint. So there are commercial paint mixers and dispensers, although the machines do not usually do both and are very unsuitable for the average classroom and amateur artists. Commercial paint mixers and dispensers deal with very large quantities of paint, making it both unideal and too complex to have in the classroom or hobby artist setting. Not only that, but these commercial machines can range anywhere from $2,000 to $6,000. Our product would be more simple and affordable. Using our design, artists will only require 5 paint colors in order to make any color that they would like for their projects. So next up is our project goals and deliverables. So pretty much we want our project to be able to dispense a given liquid autonomously, and we want that to be able to dispense in less than 1 minute. Another thing is that the liquid volume should also be within 10% of 10 milliliters. There are also going to be 3 different types of user selection methods. So the first one is the 7 colors of the rainbow. The next will be the color bar chart or the hex value theory. And then the last one will be the color match scan. And so we want our project to be able to dispense the required paint to make the color and also have the ability to mix that color in order to create the one of the user's choice. So next up is our project implementation. And so pretty much with this, as you can see, we have our 3D print where all of our pumps are housed, as well as the containers where our paints are sitting in them, along with the motor and then the mixer. And behind the 3D print, you can also see that there are the breadboard and the motor drives and motor chip that is all connected and wired up to their individual components. And then within the box to the left, the white box is where our Raspberry Pi is stored, as well as our color match scan and our touch screen as well for where our GUI interface is.
So after discussing about the pump and motor, next up is our actual color sensor and the design of that. It's basically a pretty simple color sensor. It's nothing fancy. It's the TCS 3200 color sensor. And the main job of this is to basically convert light intensity into a frequency that would in which we can then read and determine what color to make. And then we have this sensor nested within our design and able to block that noise that you might get from some of the light in the room. All right, so talking about software, these are just some design requirements that we came up with of what we wanted our software to really accomplish. First is just it being able to receive input from the user, whether that's a button press, sliders, numerical entry. We just wanted the user to have the power in this device. Next is to actually be able to perform that color conversion from RGB to CMYK, or vice versa, whatever we needed to do to make the colors needed. Thirdly, to determine the order of the pumps and the amount of time necessary to create a desired color. This is essentially just not every pump is running the same. Some have different flow rates, so we needed to calculate that in order for each color to dispense out individually. That way we can make whatever color we want. And the next is be able to mix all the paint that we dispense thoroughly and completely. That way it will mix all the way through and we can make the color and actually looks like the color after it's done with the mixing process. And finally, we want to allow the user to make as many colors as they wanted until they didn't feel like making any more colors. All right, so this goes more into the individual software design. This kind of goes along with the block diagram. First, is just real boring stuff. You initialize all the pumps, color sensors, stepper motor, motor drivers, all that stuff. That's the boring stuff. Now, into the actual, meat of the code that actually does stuff. We started off with, okay, we have to be able to turn on any pump at any time. And this allows us to dispense individual colors separately. That way we can dispense them, individually at a time to make whatever color we want eventually to dispense them all at the same time. So we needed to get that down. Next is just to be able to turn on the motor to actually mix whenever we needed to, and set a time for that to mix after the colors have dispensed. And then next is just be able to calibrate any input from the color sensor, so we can actually make that color. So take any of that data and convert it from the light intensity to the frequency. And then the last two, we needed to develop a multi-layered GUI, so you had different options. So it wasn't very basic. We first started with a basic color scheme of just, okay, choose a color of the rainbow. But then we enhanced it to involve more complex colors where you could have a sensor where you could, have like one of the example colors, put it up against if you want it, and it'll make that color. Or we have a RGB and a hexadecimal entry where you can make even more complex colors if you know the values for either of those and convert that to CMYK. And then based off of any input that you are given in any of those three, the software will then dispense any color. Will dispense all of the colors needed to make that color with the precise times and with the precise times to mix as well.
All right, so going into a little bit more detail on kind of what our code does is, so we start off with basically all the values we're getting are in the RGB form. So we need to convert those into the CMYK that our project is based on. So we basically have equations that will map the RGB values to CMYK values to create the colors in the real world. So we utilize color theory in order to add white to our design because the CMYK model does not use white, it uses a blank sheet of paper as the background. And so we developed a new equation to come up with that white value. Based on this information that we've created with the CMYK values, we were able to build a data frame in which we used the flow rates we had previously determined to calculate how much each pump needed to be turned on based upon the colors needed. Our next hurdle kind of involved the K value. In CMYK, K is the black color. And one of the main differences between printing, which is where you typically find CMYK, and paint mixing is that black or K has a much greater effect. So the amounts of black or key that you would use while printing are way too much and kind of totally overload the paint sample when you're working with paint mixing. So we needed to determine a way to scale that K factor down. So we did several tests to determine the correct scaling factor there. Finally, kind of the next hurdle we had was with the sensor calibration. It's kind of fitting the sensor into our final project. The color match sensor had to be calibrated using paint chips provided by manufacturers. We scanned dozens of chips that had known RGB values, and then were able to map those values to their correct RGB values in order to determine the correct formulas needed. So here you can see the graphs we generated throughout by using MATLAB's curve fitting toolbox. In the top left-hand corner is the R value, and you can see the function maps pretty closely between the sensor value and then into the correct R value. The other top slide, you will see the green value, and at the bottom, you'll see the blue value. As you can see, in the beginning, we had a lot of kind of extraneous data with the blue sensor. But however, once we implemented our nesting design, we were able to kind of get rid of some of those extraneous data points and get a much more accurate curve fit.
So in this slide, we're basically going over our accuracy of our pumps and the sensor. So in this left-hand table, we are citing how accurate our color pumps are. And we had a pretty good error percentage. It went from 0.05 up to only 4.4%, even though we had a small sample size of 10 milliliters. And then the table on the right is our sensor, or gives the accuracy of our sensor. And so this actual column is the actual RGB value given by the manufacturer. Then this middle column, the sense column, is what the color sensor picked up, and then the error is the discrepancy between the two.
So as for challenges and bottlenecks, one big one was making sure that we keep the tubes clean. Um, we don't want anything drying up or crusting in there. Also, color contamination can be an issue when dispensing paints. It gives us the wrong color. The mixing design implementation and mixing without spilling, we just wanted to make sure that when the motor spun and it mixed the color, that it didn't get any out of the cup, so that we wanted to make sure that the cup was tall enough and the motor didn't spin too fast. Also, 3D printing failures and makerspace availability became an issue, especially if we were on a time constraint and we needed parts.
Another challenge that we faced was when we were trying to drive the stepper motor used for mixing. We were using a BJT based motor driver, and that was causing us issues, mostly because we were using a Raspberry Pi, which caused additional challenges. So instead, we switched to a MOSFET based motor driver, which made it a lot easier to drive the stepper motor.
As for future directions, we would definitely want to add a sixth pump in a water reservoir to help with cleaning. Cleaning was a big pain without that, and we would always have to do a lot of back and forth to the sink. App implementation and more wireless components are a big thing too. We definitely want to make this more wireless and more accessible to more people so they can control this via their phone. And then, of course, machine washable mixing cups would be super useful, so they don't have to wash them individually by hand. That definitely took a long time. Thank you.